All right, this is part 6 of the sampler Loopstation tutorial. Last time we made a record button. Well, basically we just made it so that if we clicked our thing, our little patch there, sketch, it would record. So this time we're going to make a play area as well, but then we have to do a few graphics things. So if we want to have two different areas that we click, basically like a play and a record, we're going to have to designate certain parts of our sketch to be able to do that. Might be nice to have a little bit of graphic feedback for that as well. And finally, we do have to actually set up the play button to send these OSC messages to play. And we have to get SuperCollider ready as well, which, do we have something? No, we just have record on, record off. Okay, so let's get started then. Why don't we first change the record button so that it only, if I run that, we'll just remind ourselves how this looks. It looks like this, but why don't we set our record button so it only starts recording if we press on this half of the sketch, okay? And then we'll make this the play and the play and stop side, the play and pause side, okay? So we can do that fairly simply. First of all, we got to see, right, so right now this is where it happens, right? So let's make a little comment here so that we know this is turn record on off. Okay, so that these messages here, Ron and Rof, turn the recording on and off. It sends a message to SuperCollider to do that. So basically we can just, and it happens when we press our mouse, right? So basically we just use an if statement, make a condition that says only when we press our mouse, but only if the mouse is actually located on the left half of our sketch. Okay, and so if we go if, and we just set a condition, we say mouse X. If you remember the mouse X variable, built-in variable, it continuously gives the current location of the mouse X when it's over the sketch. Okay, and then we can say is less than, and then we can say we have a variable. Did we assign a variable to the width? Do we have a W and a no, we don't. Okay, that's okay. Well, we'll just use the width variable. So if mouse X is less than the width of the sketch, another built-in variable, okay, that'll give you the width, and then that's basically all of the width. So that's just like what we had before. So we can just say width divided by 2. Okay, if mouse X is less than width divided by 2, we'll open the scope of the if statement and we'll end it down here after everything, right? After all we can control tab. Oops. Well, let's not do that. Control tab to get that going. Control T to re-indent everything. Okay, so now only when we press on the left half will it work, and when we press on the right half it won't work. I'm just going to demonstrate that. We'll print it. We'll just do something, just print anything really. So if we look down here, when I press here, it prints. When I press on this side, nothing happens. Okay, there. All right, so we have that working. Now let's do something so that it gives us some visual feedback so we can see what happens. We can get rid of this. All right, and then we're going to go up into the draw area. And well, let me just take note that this happens based on this rectog, right? So we have these two if statements. If rectog is 1, then we send the message on. If rectog is off, we send it off. And only when the mouse is pressed, right? Okay, so we can use that that variable, rectog, that's available. It's a global variable, right? It's all the way up here. It's a global variable. It's on the root. It's available everywhere. So we can use a draw to draw something over. So why don't we draw a little sort of a transparent, maybe like a red area so that it sort of glows red so that we can tell we're recording. All right. So we're going to now draws everything in order. So it draws the measure markers, then the beat markers, then the cursor. So we're going to put this kind of over everything, but make it transparent. But maybe under the cursor, huh? So the cursor will still be on top. But so we'll say record highlighting. So this is, I didn't spell that right, but that's okay. High, H-I-G-H, light, L-I-G-H, T-I-N-G, something like that. I'm a terrible speller. Oh, well. Okay, so record highlighting, and then we're just going to draw a box over the whole entire sketch. So let's put all the parameters in, though, because we don't know, our graphics could get a little bit fancy. We don't know what's going to happen. So that just means that we're just make sure we set our stroke to 0, or no stroke, actually, we say, right? And then we set a fill. That's for the rectangle. And we're going to use transparency here. I'll do sort of kind of a reddish fill. So we'll just use red, 25500. Okay, that's red. But we'll set the transparency to say something like 50. Okay, so that's the alpha channel. It's 0 to 255, 255 being completely opaque and 0 being completely transparent. All right, and then we'll draw a rect. And we'll start that rect. What's the XY position? The top left corner will be in 0, 0. And let's see, then we'll make it, the width will be the width of the whole canvas or the sketch. Use that built-in variable width, turns pink. And the height will be the height of the whole sketch, which you use that built-in variable height. Okay. And so this will just happen now, right? Once, if I run it, it'll be there. See, it's just highlighted like that. So, but we only want it to be highlighting when the record toggle is on. It's 1, right? So let's make that slightly more opaque, and we'll use an if statement. So we'll say if, only if rec tog equals 1, right? And if it's not equal to 1, if it's 0, then it won't draw any of this. Okay. Okay, so remember, and then this is a good way to test the right side, left side thing. So we're clicking on the right side, I'm clicking away there, and nothing's happening. But if I click on the left side, it turns the record on. If I click again, it turns it off because rectog is 0. Okay. So there we have some visual feedback. And let's do the same with play. I guess with play, though, it's just playing, right? So want it to be highlighted, or we have to some indication that it's paused, maybe like a grayed out or something like that. But actually, I'm getting ahead of myself because we haven't even set up the play button. Okay, we'll do it on mouse pressed again. Now, just keep in mind that in the future tutorials, we'll probably want to relocate some of these functions and such. Left, right is okay. We might want to make some buttons. I think in the one I made, the final product, I used some buttons and stuff, but we can decide. So this is kind of a temporary thing, but it's not wasted code because we're going to essentially do the same things for whatever our final solution ends up being, except we're just going to, change the trigger for it. We're going to change whether it be mouse pressed on a button, a graphic button, or mouse pressed on one side or the other, a keyboard command, or something from Arduino. But just, keep in mind right now, we're just kind of doing a simplest prototype of pressing the mouse. All right, so right now this is record on off, and this if statement, if we put our cursor there, we see that it ends there. So we just keep track of all our curly brackets and where they end and where they, otherwise we'll get errors. And we'll take another comment and we'll say play pause. Okay, and then we'll do the same thing here. We'll just copy kind of what we have up here, relegate it to the right side of the sketch, right? So we'll do if mouse x is greater than, greater than with divide by 2. Yeah, that should be fine. And then a bunch of stuff. Okay, make sure we put the 2 curly, the close and the open. Now we'll have, we're going to need to create a variable that's the play toggle. So we'll have a toggle play, and just, you remember, I hope, all the modulo stuff and how we can just get a toggle between 0 and 1. So we'll have a play tog, and we'll set a default value to 0. That's a global variable. It's on our root. So, and we'll just do the same thing. If, oh no, I guess we're gonna increment it first. But in this case, let's not increment it first because we want it to be playing. We want it to actually be playing. So we can do one of two things. We can copy it the way we're doing here and just increment it first. Well, let's do that because that maybe makes more sense. But we'll start it at 1 because we want it to be playing. You know, when we start, we want it to be playing, and then we want to actually pause it, stop it when we click. Okay, so then we'll just copy that format. We'll have playTog equals, and then it's playTog plus 1, but we're going to do the modulo 2, so that it only toggles between 0 and 1. Okay, so then we can even comment this increments to play the toggle. Okay, and then now we'll have our 2 conditions. So we're going to either have a toggle at 1 or toggle at 0 if playTog equals, and I guess we start with 1. Then we're going to send some kind of OSC message. Else if equals 0, we're going to send some other kind of message, okay? But established those messages yet. We haven't built that in SuperCollider. So let me save that. Let me pop over to SuperCollider. Shrink that a little bit so I'm not working at the other side of the page. So basically we have now something similar to that. We have to create these OSC defs, these listeners that are going to listen for a message from another program and execute a certain thing. And let's go all the way back and just see how this works, okay? So, oh, maybe we do need the full page. So I'll go ahead and do that, and I'll just sort of scoot my chair over. Okay, so let's back up a little bit. Remember, we need to do that in SuperCollider first as a sort of a manual thing. If you executed this code, you're going to achieve certain things, and then we're going to back up and repeat those tasks within an OSC def, so it just remote controls those tasks. Okay. So what we need to do is when we start our initial synths here, we started an index synth, we started a record synth, but we also need to start that play synth, the one we built way back when, the buffer play. Okay, and we did this here as an exercise, so we'll just pop that in there. I'm gonna, I should recopy it just so we could be that, and I'm gonna give it a name. I'm gonna call it play. Let's see what I called it. Did I just call it play synth? Play synths. Okay, play synth. Okay, and we'll equal to a synth. Okay, and it's going to be based on the synth def buff play PL. Okay, comma. Next argument. Now all the initial arguments will be in that array, and then the third argument will be that target. So we did create a group for it. If we go up and look at it, we have an in group, IX group. Sorry, and remember this is the programming thing. This is the programming order of operations. We have an in group. And then we have an out group, OGR, okay? So that which happens after the in group. So basically we can record and then we can play after that. So that happens first and that happens second. So that, we can actually play back as we're recording if we want. So OGR, that goes in, when we're starting a synth, that becomes right here after this, the third argument is the target or the target group OGR. That's going to be the group. So for that order of operations. Now, what initial conditions do we have to set? Initial arguments do we have to set in that array? Well, we have to set the buffer, and it's the same buffer, sound buff. So we have, we're writing to the same buffer we're reading from. So we record, and then we can sample ourselves, and then we can play back. So it's the SND buff, same as the rec synth, the buff record. Okay, and then we're going to get an index bus. That's the bus we read the indexing information from. So we're all coordinated. It's the same one. So the argument name is index bus, and the index bus name is IXA bus. So it's the index audio bus. It's the audio rate index bus that we created. Up here, IXA bus. It's an audio rate. It controls our objects, sends that phaser in as an audio rate object. And it looks like that's it. Oh, and then we're going to start it as a gate 1. That means we're going to start it playing right away. Okay. That's just going to put that envelope up to 1, and a signal will be coming out. Otherwise, our out signal will be 0. So we're going to set that gate to 1. Okay. So that when we initially start everything, it will be running. This play synth will be running. It will be playing back. All right. Okay, so we have that going. Now, basically, we have the synth, which is this variable name, play synth. Okay, and then we have to just deal with that now. So once that's running, once we start our code, all this stuff will be running. And now we're just going to do these set things again. We're going to set the arguments to change if we're playing it or not playing it. Okay, and I think PlaySynth is kind of easy. We can have it because it's easier than the write, because we can have it playing in the background and just no volume coming out. So we can just set the envelope to 0 if we want, and that will be fine. That will make it so that we're not hearing anything. It's essentially being paused, even though it's still reading that. It's still reading the buffer. It's just no sound is coming out because the envelope is 0. Now, I think, you could run into maybe some troubles if you have, a whole bunch of lots and lots of tracks. Then maybe you don't want all these things running. It's more efficient to not have these play synths running because they're still running. But in our case, I mean, we're not going to have, that many tracks running, and the computers these days can handle, loads and loads and loads of playbacks. We'll let it run in the background, and we'll have no volume come out, just for, simplicity in our programming. Okay, so you saw I copied that OSC def, but let me not do that. Let me just retype it. It'll be worth doing it. So we're going to create an OSC def, and then we're going to create, we're just going to set up the basic structure there with the scope. We're going to give it a name, and I'll say play, and then a comma. Our next argument is the actual function that's going to run when we receive an OSC address, which is the third argument, and that's going to be play as well. Okay, so play being the internal name that SuperCloudr uses, so we can refer to it kind of like this, this set, this free. We can use that as this is the variable that we refer to this OSC def. This is the function that runs when it receives this message. So this is the message it's waiting for, play, and then it runs that function. Let's stick a couple lines in so that we can have some space to work. And then basically, we don't have any arguments come in, so we don't worry about that. We'll have to change that later when we have more than one track, but that'll be sort of the multi, making multiple versions. Now, we just have to take this play synth then, and then we have to set the argument of gate to 1. Okay, so that's just going to turn our envelope on and allow that information to come out and be playing. All right, now we'll make a pause one, and this one I'll just copy and paste. So we'll make a 1, but just make sure we change all the variables. This is a very common one to leave unchanged, so that when we execute these, it records this OSC def as play, but if you forget to change the name and this is still play, it'll just erase that OSC def, this one, and then this will be play, when actually it's a pause one. And of course, we want to wait for a different message. We'll make that pause as well. We're still setting this play synth, which is initially set up when we execute, when we initialize all the code. It's already running, and we're going to set the gate to 0 very simply. It just turns that envelope off. We can look at the synth def. You have an envelope, and it's multiplying the in signal, which is coming out from the buffer. Okay, so it's reading this buffer. Oh, sorry, this is the buffer record. Sorry. The signal is a buffer read. It's reading this buffer, right? The sound buffer, whatever we recorded, and it's sending out that signal, that buffer that it's reading, and it's multiplying by this envelope. So if the envelope is 0, the signal is just going to be 0. If the envelope is 1, the signal is going to be coming through. Okay, so we have simply set the envelope to 1 and 0, and that, because it's an envelope, and that's the reason we put in the envelope, is it has a wee bit of a an attack time and a release time. We're just using the defaults there so that it doesn't click when it comes in. When it plays, when we hit play, it doesn't click. Okay, so that's pretty much it. We have a pause and we have a play set up now. OSC defs. Okay, let's go ahead and we'll just run all this code. We'll boot our server because I think this is complete. We'll run all the code and make sure it works. It seems to be fine. Start our initial synths. So an index synth, a record synth, and a play synth. That seems to be fine. And then we'll go back to our processing. So that's running in the background. And you can see here it's minimal. It's taking a 0.2 or 0.3 at the most capacity. All right. So going back to the processing side now, we have to do something similar to what we did with the record on and off. We are sending a messages. So we have our conditions. If the play toggle is 1, then we're going to send a message or do something. And then if the play toggle is 0, we'll send a message or do something. Okay, so let's format our OSC message. So if play toggle is 1, that means it's playing. We can even comment some of this stuff. I can say to play. And then we can do an OSC, capital OSC, MESSAGE with capital M. And we'll make a temporary variable there that's just a holding place. We'll call it play PMSG maybe. And it's going to be initialized. It's going to be equal to a new OSC message. And then it takes one argument, which is the OSC address, which we called play right there. Okay, so we'll say play. Quotes with that /. Make sure we do that. Now we just basically just need to send the message because this is waiting for play. Once it receives play, it'll execute that command. It'll just say set. So we don't need to send any additional information. So we'll just use our OSC machine and we'll do send, use the send command. And we'll send what? We're going to send the PMSG, the P message that we created. And where? It's going to send to our net address supercollider SC. All right, so we'll do the same thing here. I'll just copy and paste. And we'll change the name of this. This is a pause message. I guess I'll just call it PS. I'll make sure I change it here as well. And make sure I change the address because we're not sending play, we're sending pause. And we'll make sure that harmonizes with our supercollider pause. So we're sending the pause message to supercollider in this case when the play toggle is 0. Okay, so that looks pretty good. And now the last thing we need to do is then have a highlighting or some kind of visual thing. So what I really want to do really is only highlight when I am paused, right? We'll have some kind of gray out. How about that? So what I'll do is I'll make a little comment and I'll say play, or we'll just call it pause highlighting. I think I spelled it right that time, maybe. Okay, and again, our condition is if the play tog is equal to 0, right? Because we only want it paused when it's paused at 0 instead of 1. And we only want this highlighting to happen when it's paused. We'll go ahead and fill in these things. They seem redundant, but sometimes we don't know what order things are executing in. So we just want to make sure that we have all these things in place. So no stroke again. And we're going to fill some kind of gray fill. So if it's just black-white kind of fill, then you can do just a single digit, between 0 and 255, 255 being black. So we'll just have a light gray fill, maybe a 40 or something like that, 40 gray. We'll see what that looks like. And then we'll draw another rectangle. And it will be at 0, 0, and width and height. Cover the whole canvas. Okay, so that should be me. Run that. Oops, missing a semicolon, right? I did colon instead of semicolon. Okay, and run that. Let's see what happens. So if I click on the right, it turns gray. Ooh, right. I didn't put a transparency. Sorry. So that's the shade of gray, but it didn't have a transparency. But we see that works. This works as well. Colon instead of semicolon. Oh, and it records. Look at that. How nice. And run that. Let's see what happens. So if I click on the right, we'll let that go. I know it's been annoying. I'll quickly fix this. I simply need the shade of gray. Didn't have a transparency. But I need that's the amount of gray. I just need a transparency, which is again maybe something like 40. So let's run that. So if I click on the right, it turns gray. Ooh, that's okay. See, it's paused. It's really so nothing's coming out. It didn't have a transparency, but we see that works. It's paused. Okay, let me record. La 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 la. Turn record off. Or actually, yeah, that's fine. And we'll. I didn't put a transparency. Sorry. Play the shade of gray, but it didn't. We see that works. This works. Instead of semi-record. La 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 la. Okay, so that works. Great. Okay, I think I'm having some clicking issues. I think that's my sound card, and I hope that's the case. I should look at that. I don't think it's our code, but there is one thing we can fix there with our code as well. So let me just first of all, let's fix that highlighting. 40 gray, 40 transparency is too light. Let's go to 100 and see what happens, how it looks. Still quite light. Let's go to maybe a darker gray.
And run that. Let's see what happens. So
100 and 100.
Ooh, that's
Right. That's a little bit better. Okay, maybe even a darker gray and 150. But that transparency seems to be right. Oh, that looks good. Okay, let's record.
right. I didn't put a transparency. Sorry.
Okay.
So that's the
Let
shade
me
of
get rid of
gray.
this. This is annoying. Okay, so there we go. So that pretty much works. That's more or less there. Great. We have a record button. We have a play button, kind of, click on one half of our sketch. What would be nice is you'll notice, well, I'll go ahead and run this again. So we compile, boot, send this code, send that code after that code. It's going. I will run it. I'll record 1, 2, 3, 4, 5. And, all right. There is some oddnesses in there. That code, it's going. I will run it. I'll record 1, 2, 3, 4, 5. 1, 2, 3. After that code, it's going. I will run it. I'll record 1, 2, 3, 4, 5. Okay, that's working. I guess what I was trying to demonstrate is that right, when I'm recording, it actually should be playing back as well. Right, this gate is 1. Why is this gate 1? Right, okay, because initially I'd set it up to, so go back. When I started these initial synth, I was just practicing it because I didn't have the record button on yet. So the initial state of your record synth really should be gate 0, right? You don't want to actually be recording anything into it just yet, okay? And your actual initial, remember how we have this record on and off? We're set not only the gate to 1, but we reset the sound buffer. And when we want to record off, we're going to record into a dummy, sort of a 0 buffer. So that's our initial state. We don't want to start recording. So in fact, we're not going to make our buffer sound buffer. We're going to make that buffer 0. Okay, BUF. Okay, so then when we start the stuff, then we have it's not initially recording. Okay, let me just take a pause here. Well, you won't see the pause, and try to restart the system and see if I can get my sound card running. Just be right back. That's much better, but I'll finish this video. It's fine. I'm pretty sure it's not the code. Okay, so we have these initial things. Now, the only other thing that would be nice is that when we're recording, you couldn't really tell from that last example, but normally I would be recording and it would be playing out the speakers as I'm recording. You could have that. That would be nice if you want a PA kind of thing. But ideally, I would just play into it, sample it, and then only play back the recorded samples, okay? So we just have to fix a little trigger that when we record, we turn the play off, and when we stop record, we turn the play back on, okay? Very simply. So we can just use these things as well. So what we'll do is we'll just copy this set play, okay? We're going to copy that because this will start our play. And we'll say when we record off, we're going to also restart our play. Right? That makes sense? So when we turn the record off, we shut it. We're kind of going backwards. So let's start here. So when we copy that pause, when we start recording, we're first going to pause our play. So when we send record on, we're going to pause the play first, and then we're going to start recording. Okay? And so the playback won't happen. When we turn the record off, then we can start the playback again. Back up. So that's just not coming out because it'll play what we're recording. Remember, because of this usage of group, we have our record signal going in and our playback signal coming after that. So you can play the samples we are actually recording. All right, let's give that a shot. It still might sound a little bit messed up, but I think that's just my sound card. And I will send this to go, and then I'll send these synths to go. And now with the 0 buff and the gate 0 on the record synth, we're not right now recording. Okay. And then I will start my interface. And we don't hear anything, nothing. I guess I can turn this up a little bit. But if I press record, 1, 2, 3, 4, 5. And we don't hear anything coming out, right? Because it paused the play. And let's see if that works. 1, 2. I can pause it. 4, 5. Oh, it sounds better even. I did get it sort of sorted a little bit. Okay. And we can record. Hello, 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 hello. 1, 2, 3, 4, 5. That's a little clip there. I'm not sure what that's about. Record. Hello, 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 hello. Still a lot of clipping there. Oh well, I'm sure that's just my sound card acting up. Okay, so yeah, so there you go. We have this all set up there, working. I think we'll call that a day for this tutorial. So basically, what we did was just we added a play button, and we added some graphics to show that we knew when we were playing and recording, and we fixed up our OSC depths and such. Our initial synth did some tidying up there, so that when we record, we're not playing back, and when we off record, we turn the record off. The playback starts again. All right. Well, we'll progress next time with. I'm not sure what we'll do next time, but good luck with this bit.